Okay, so here is a video on graphing compound inequalities. So if you will look at the next page in your notes, it says a compound inequality consists of blank distinct inequalities. So compound inequalities are just inequalities, but there are going to be two of them. So you've got two inequalities joined by the word blank or blank. So our two words are going to be and or the word or. Okay, so again, compound means there are two of them, and then they're either going to have the word and or an or, and that's going to show us how we graph them a little bit differently than we're used to seeing. So let's talk about and inequalities. And I think of a sandwich. So you're going to have something like maybe a closed circle, maybe an open circle, and with ands, you're going to shade in between them. So with and, they're going to overlap, they're going to shade in between. So let's look at some and problems. So here is what a compound inequality looks like. I want to know when is x greater than or equal to a 3 and when is x less than or equal to a 7. So to see that, let's graph x is greater than or equal to a 3 on the first number line, and then let's graph x is less than or equal to 7 on the last number line. So I would go to a positive 3. It is going to be closed in. And then for greater than, I would shade to the right. For x is less than 7, I would go to a 7 and shade it in, and then go all the way to the left. So when is a number greater than 3 and less than 7? Well, that's going to be this overlap right here. So here is my overlap. Okay, so what you do is you just graph that all together on one line. So I'm going to start at a 3. I'm going to end at a 7. And then it's all these numbers in between. That would be my solution set. So with and problems, you're trying to figure out when it's greater than or less than usually, and that's always going to be this overlap. So and problems are going to go in between each other. Okay? So let's look at how we write them next. So and inequalities can be written in two different ways. They can have the word and, like you just saw, or they can be all squished together like so. And how you get from this to this is pretty simple. So notice here's an inequality that looks the exact same. They literally just wrote x is less than 7, x is less than 7 right here. But notice this smaller number, this is kind of switched around. So what they did was they put the x in the middle, the 3 on the left, and then they had to match that sign, and then they could write it down there. Okay, so when you write an and inequality like this is always going to be the bigger number. This is going to be the smaller number. And your signs are always going to go the same direction, okay? So if you put the bigger number on the right, the smaller number on the left, you're going to have the inequality signs facing the same direction, okay? So let's kind of practice that. So I need to write x is greater than 2 and then less than a 7 as a compound inequality. So I'm going to write that with an x in the middle. My signs are going to be facing the same way. Actually, I'll come back to that in a second. So out of a 7 and a 2, which number is bigger? That would be a 7. So my 7 would go on the right side, and then my 2 would go on the left side. So now I need to match the inequalities. So this inequality was opening up to a 7, so that still needs to happen. And then this inequality was opening up to the x, and that still needs to happen. Okay? So that is how you write that compound as an inequality without using the word and you notice the bigger numbers on the right, smaller number on the left, and your inequality signs are facing the same direction. So now we can graph that, and since it's an and problem, they're going to go in between, but I would start at a 7 and it's going to be open. And then I would go to a 2 and that would be closed. And then I would have to shade in between those. Okay, so 2 could be a solution, 3 can be a solution, but 7 is not a solution. So notice it's going to the left of the 7, but going to the right of a 2. Okay, so that's an example of an AND problem. Why don't you try this one on your own? Press pause and try and write it without the word and then graph it as well. Press pause. Here is what I got when you write it all smushed together. Notice I had to start with my larger number, and so since 10 was bigger, it's on the right. -4 I put on the left. My inequality sign was opening up to the 10, which is still true. And then my x was opening up, and it was opening up to the x. Next thing, this is an AND problem, so I'm going to shade in between them, like so. And so -4 would be a solution, and anything in between except a 10. That would not be a solution that fits that. Okay? All right, why don't you try these 3 on your own? You are going to have to draw your own little numbers, but go ahead and do that and press pause, and then we'll go over the answer. So here is what I got for these problems. Why can't I move this? Okay, so when an x has to be greater than a -3, we went to the right, but then also less than a 5, so that's going to shade in between those. They were both open because there was no line underneath them. On number 2, it has to be less than a 7, but greater than a 0, so all of these numbers in between would work. Again, they are both open because there was no equal to. 3 is tricky. Just because you see the word and doesn't mean you can just shade in between them. Because if you notice, z has to be greater than a 5, so going to the right of a 5, but then z also has to be less than a 3. So, can you pick a number that is greater than 5 and less than a 3? No, like that's physically impossible. So what you would do in this case is it's no solution. Okay, so if you have an AND problem that's going opposite ways, that means you know it can't happen. So that would be a no solution. Okay, that was tricky. All right, let's look at some OR problems now. OR problems, or go opposite ways. We'll say opposite directions. So that means you're going to have some kind of a line or a dot. Maybe that's one's open. You're going to shade left, and you're going to shade right. So or go opposite, or opposite. So let's look at these problems. I need to see when x is less than a -2 or greater than a 1. So I am going to first graph this one, and then graph x is greater than a 1 on this line, and then look at the combination in a second. So when is x less than a -2? There's -2 going to the left, and then I want it to be greater than a 1, so it can be equal to a 1, and going this way. Okay, so notice there was no overlap because it's to the left of this -2 and then to the right of this 1. So when I combine them on the same graph, I literally just redraw the same thing. So my final answer would be open at a -2 going left, and then closed on a 1 going right. So when you have OR inequalities, they're going to look like this graph right down here. All right, so let's look at some examples. Real quick, OR will always have the word OR, okay? With those AND problems, it could have the word AND, or it could have, you know, no AND with smushed together, but OR will always, always, always have the word OR. So let's graph this compound inequality. I'm going to start at a -1 and go to the left, and it's going to be closed in. And then I need it to go greater than a 3, so open, shading to the right. All right, so this looks right because it's an OR problem, and my circles are going opposite directions. So what this means is any number on this side satisfies the problem as well as any number on this side. Just make sure not 3. So why don't you try the next one on your own? So try these 3 problems and then press pause and we'll come check our answer in a second. Our answers for number 4, I started at a 0 and kind of drew some negative numbers and some positive numbers. It's open on a -3 going left and then open on a 2 going right. So that looks like an OR problem. They were going opposite directions. On number 5, maybe your number line didn't look like this, but as long as you had 15 closed in going left, 25 closed in going right, you would be correct. And then 6 was a little tricky. So it was an OR problem. However, I had to shade left of the 7, but then right of the 4, which technically covers the whole entire line. So this is a special case. So when you have an OR problem that is covering the right side and the left side, that's actually going to be all real numbers. You could also say infinitely many solutions. So infinite solution, infinitely many solution, all real numbers, anything like that. Again, so if you have an OR problem that is wanting you to shade and overlap the whole number line, all real numbers, or many or infinite solutions. Goodness. Okay. So now you get to practice more with IXL. I love it because it's just graphing, and graphing is obviously fun on IXL. So if you will log on, it is K12 and K13. It's on the back page of your Inequality IXL paper. And then remember, it's first initial, last name. Your password is Fulton 2020 if you are a sophomore or freshman, sorry. And then 85 equals a piece of candy, but you can totally get to 100. So go ahead and get started practicing. Let me know if you have any questions.